Okay, so the next two lessons I really do as one. So you can see that it's 2.7 and 2.8, but I just kind of combine them because they're very similar. Segment proofs goes with 2.7, angle goes with 2.8, but this is your notes for both of them. We are going to take probably 3 days to practice this lesson. There's not a whole lot of necessarily notes, but it's just practice, 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 practice. So our next test is looking to be next Thursday, and it's going to be a proof test. So your whole test is going to look a lot like this. Okay? But we're going to practice, and you're going to be great. So there are a couple things that you already know that we need to remember, and there's really not a whole lot of newness to this lesson. It's just putting stuff, using stuff that you already know. So number one, we used in our math workshop. What's it called when we take this plus this and equal it to the whole thing? Segment addition. Now, when you're writing this in proofs, I don't mind if you write seg add post. But right here, write it all the way out so you remember what it says. So you have segment addition postulate. Well, the second thing you need to remember is that WSQ, so this little one, plus this little one, equals the whole thing. And that concept is not new, but the wording is new. You actually have angle addition postulate as well. Angle addition postulate. Okay, step 3, or number 3. If R is the midpoint of QS, then QR is congruent to RS. Your reasoning from going from step 1 to step 2 is called the definition of midpoint. If something is in the middle, then you can write that they are congruent. Four, BD bisects ABC. If it bisects, it cuts it in half, which means angle 1 is congruent to angle 2. This is called the definition of bisector. Can you also have a definition of bisector in a line segment? Yes. And those are kind of similar to midpoint, right? But it depends on how it's given to you. If something says, I bisect this line, then you need to use definition of bisector. If it says midpoint, then you need to use midpoint. Okay, that's really it. That's really it. And now we just have to practice. So on number 5, let's take what we're given. AB is equal to 12. BC is equal to 9. Okay, well in step 2, what are they using? So I'm going to use seg add post. What happened in 3? What happened in 4? Yes, I like to use combine when they're on the same side of the equal sign. Technically, you're not wrong. I just like combine. And then what's 5? Symmetric.
So basically we're doing the same thing, we just added 4 different ones.
And yes, and there's all different like types and varieties. So basically, you did algebraic to get like the process down. Now we're going to add like algebra, geometry, angle, segments, everything. Okay? All right, 6. AB is equal to 5. AC is equal to 18. That's what we're given. Well, what's 2? Yep. 3.
So that's usually
4.
something like
Yes. Progress reports are important.
Yeah.
They printed them yesterday at 10 a.m. All right. 7 and 8. We really covered this yesterday. Remember, if they are congruent, we have to go through the step to set them equal. What's the code?
Definition of congruency.
Good. Definition of congruency.
Is you recording this? Yeah.
Those are tears. Huh? No, they're tears because she didn't know how to spell definition.
So is
Okay.
the definition of equals?
No, it's just the same thing. It's the same thing. So it's just showing you that it's the same thing if you're going from congruent to equal, or if you're going from equal to congruent, it's the same thing. Yes. She just said, do you know how to spell that? Okay. Hold on 1 second. Y'all finish 9 and 10, okay? It would probably say it up here somewhere. Okay, 9. B is the midpoint of AC. So the reasoning is definition of midpoint. Well, from 2 to 3 is definition of congruency. Um, 5 is just substitution. And then 6 is symmetric. Yes. It could also be. I see both ways. I do. You see, that's a great question. She said, could it just be transitive? I see both ways. Because BC right here, they're equal to AB. It's cutting AB out. But you could also just say, well, I plugged 5 in. Okay? 10. This is ang addition postulate. This is substitution. This is combine like terms. This is symmetric. Yes. What? You what? Okay, 1. So now you're done practicing, and you actually have to write your proofs. So statement, reasoning. You can write AB equals 7 and AC equals 15 on the same line. So this would be given. I'm sorry. Okay. So then 2. Well, you know you're probably going to have to use segment addition postulate. Because AB is 7, AC is 15, and you want to prove that this is 8. So you know that AB plus BC is equal to AC, and your reasoning is segment addition postulate. So step 3, I would plug it in. So you get 7 plus BC equals 15. What's 4? Did we prove that BC is equal to 8?
Yeah.
We're done.
They always say that.
Sometimes. Okay, your homework. I want you to finish this packet.
That's not bad.
It's not bad. It's 4, and one of them is fill in the blank. So it's 3 proofs. Okay? You have about 5 minutes. So I bet you could get